This lecture will introduce monitoring concepts. Modern applications operate in a very large, distributed computing environment. Many components of the environment may affect the performance of an application, such as network, servers, and various pieces of software. For database administration, we want to focus monitoring on the database server. To be more specific, we want to monitor the database server resource utilization when the SQL code is running. We want to monitor CPU, memory, disk, and network connection. Baseline is a very important concept. Baseline consists of a set of performance numbers gathered under normal circumstances. We will use baseline as the standard when we conduct monitoring to determine whether there is any performance issue and how serious the issue may be if there is an issue. When we conduct monitoring, it's imperative that we have clearly identified objectives. Why are we monitoring? Are we monitoring to establish a baseline? Are we monitoring to determine the growth for capacity planning? Or are we just monitoring to troubleshoot a specific performance problem? Clearly identified objectives will help us stay focused. The monitoring methodology is not complicated at all. First of all, we want to make sure that we have a current baseline. If we don't have a baseline, we need to establish one. If our baseline is outdated, we want to update it. We want to gather current performance metrics. Then we will compare current performance metrics to the baseline to determine whether there is any performance problem and how serious the problem may be if there is a problem. There are many tools that can help us conduct monitoring. We can use the tools that came with the database management software, such as Activity Monitor, SQL Server Profiler, and Extended Events. We can also use tools that came with the operating system, such as Performance Monitor. If we can justify the business needs, we can implement a third-party integrated tool to monitor our overall database infrastructure. We can always use SQL statements to gather performance data. When we conduct monitoring, a very important consideration is sampling time and sampling frequency. We want to take the monitoring samples at the right time so that we can capture relevant data. Generally speaking, the shorter the monitoring period is, the higher the sampling frequency is. For instance, if we are monitoring the database server only for 20-30 minutes, we will most likely take a monitoring sample every 20-30 seconds. On the other hand, if we are monitoring the database server on an extended basis, then we will probably take a monitoring sample every hour. Keep in mind, the more monitoring samples we take, the more disk storage we will need to store the performance data. Monitoring puts a load on the database server as well. We do not want to over-monitor. Especially, we do not want to over-monitor a production database server. If we have a very large database environment that we need to monitor, we want to consider implementing a centralized monitoring solution, such as central management server or a third-party integrated tool. We also want to consider using a management data warehouse. A management data warehouse can enable us to store performance data on an extended basis for various analyses. In summary, a good monitoring strategy should have clearly identified objectives. A good monitoring strategy should be effective, efficient, but less intrusive. A good monitoring strategy should meet business requirements. In the real world, quite often, we need to troubleshoot slow-running queries. There are many things that we need to pay attention to when we troubleshoot slow-running queries, especially memory and indexes. Quite often, slow-running queries are related to memory and indexes. When we design a database, we normalize the database to the third normal form. In a production environment, a fully normalized database may not perform well enough. In those situations, we may choose to introduce some controlled redundancy. That's the so-called denormalization. Simply speaking, denormalization will speed up query performance, but denormalization may slow down updates. Denormalization may sacrifice the data flexibility. This concludes the lecture on monitoring concepts.